Hello, cluster kids. Today is about adding and subtracting. I'm going to separate it into two videos, but you will only have like less than 10 problems to work on or do. Also, I'm going to try to catch up on your work. My seniors are done, so I'm trying to get them out, and so then I'll be able to catch up and update you guys on your work. So here we go. Let's start. All right, so again, we're still working with rational functions, and rational functions, again, are functions that are expressions have variables in your denominator. That's basically what a rational function is. So we need to add those. So we are adding fractions. And before we start, remember to add fractions, you have to have the same denominator. You can't add a fraction unless they have the same denominator. So let's look at it. We do not have the same denominator right now. So we need to find the common denominator. So the easiest way to do that is to look at each denominator in terms of their factors. So I'm going to break them down. So 4x is like 2 times 2, or 2 to the second power, times x. 6x is 2 times 3 times x. So whenever you want to find the common denominator, you can take each term that you see in each of the denominators and then take it to its highest exponent. So you want to see each different term that shows up and take it to the highest exponent. So 2, I need a 2. Number 1, because 2 are in both of them. But the problem is I need the highest exponent. So I have to take 2 to the second power. Then I need the 3, and I need the x. And if I multiply that together, that makes 12x, the denominator that I need. All right, so let's go back. We need to change each one of those denominators to 12x. So what do I need to multiply for the left fraction, the 2x minus 5 over 4x, to get it to turn into 12x? Well, I hope you said a 3. And whatever I do on the bottom of a fraction, I have to keep the value the same, so I have to do it on top and bottom. And over here, I need a 2, because 2 times 6 is 12. And whatever I do to the denominator, I have to do to the numerator to keep the value of the fraction. So here, if I do 3 times 2x, I get 6x, and 3 times 5, I get 15, and 3 times 4, I get 12x. And then over there, I should get 2 times 4x, 8x, and 2 times 2 is 4. And both of them turn into 12x. Now, once the denominators are the same, all you have to do is just add the numerators together, or combine. You like terms to combine the numerators together. So 6x and the 8x is a 14x, and a negative 15 and a 4 is a minus 11. So there you go. That is the answer to that. Pretty simple. It's not that bad. So let's keep going. So same thing here. Let's find our common denominator. So we have a 5x and a 10. So if we break that down, that's 5 times x. Another one is 2 times 5. We have to take every term we see to the highest exponent. All right? So I see a 2. Got to take the 2. All right? I have to take a 5. Now, I don't have to take 2 5s. I just have to write every factor that I see that is different. I'm not going to repeat the 5. It's 5 in each one of them, so I'm just going to have 5 one time. Now, if I had 5 to the second power, then I would have to take the exponent. So then I need an x. So the common denominator is 10x. So I need to turn those denominators into 10x so I can combine them and add them together. So what does the left fraction need? Well, I hope you would say 2. And then what does the right fraction need? Hopefully you would say an x. So then we are going to multiply the top and kind of simplify it out. So here we go. So 2 times 4x. So if I'm right, and remember I had to go that times that and that times that. So I get 8x minus 2. And then the other one I have to do x times this and x times that. And I get x squared plus 5x. Now the denominators are the same. Now all I care about are the numerators. So I just need to combine like terms in my numerator, and that should be sufficient. So I get x squared plus 13x minus 2 because the 8x and 5x are like terms, and I can make that 13x. And at the end, which we'll find out in our next examples, if you can factor, you have to factor. You have to keep it going because you need to simplify to the simplest form. All right, here we go. So we have one more to do. All right, they're not the same. They don't have the same denominators. We need to force them to be the same denominator. So here we go. Let's find a common denominator. So one is 2 to the second power times x, and the other one is 2 times x squared. So we have to take each term and take it to the highest, well, each factor and take it to its highest power. So that would leave, we need a 2, and we have to do 2 to the second power, and we need an x, and we have to do x to the second power. So that would make 4x squared. So the denominators need to turn into 4x squared. So let's look at our left fraction. So we need 4x squared. So what we didn't need to multiply by? We need another x. So we got to multiply times x. And then on the other side, we need it to turn into 4x squared. So obviously we need a 2. And so we're going to multiply that out. So we get 3x for the left fraction. And we get 2 for the right fraction. And all you have to do is just combine like terms. And there's really nothing else we can do here. 3x plus 2, none of those terms have anything in common all together that I can take out and simplify the terms. All right, so there you go. That was example. All right, so example number 2, now we don't have, what was different from example number 1 compared to example number 2 is in example number 1, the denominators were just one term. There was no plus or minus sign separating the terms. It was just what we call a monomial. But here we have binomials. And before we start, guess what we're going to have to do? Factor, 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 my friends. So here we go. So we're going to factor each denominator. So let's factor the first one. That's pretty easy. 5y minus 15. Well, 5 is in both terms. So 5 times y, yes, that would give me my 5 back. And 5 times 3 would give me my 15 back. So now the other one, difference of squares, always recognize difference of squares. So I have y squared minus 9 equals y minus 3 and y plus 3. All right, so here we have to take each different factor to its highest exponent. So the binomial itself is a factor. So y minus 3 is a factor and y plus 3 is a factor because it's being multiplied. So you have to take it as a whole thing. So we need the 5, we need y minus 3, that's one of our factors, and we need y plus 3. We don't need 2y minus 3 because it's only one in each. So that is taking it to its highest exponent. And so now we're going to show that as factors so we can see what each thing needs. So I rewrote the problem in its factored form of its denominator. So if I look at the left fraction, what does it need to start matching up to the other one? It needs a y plus 3. So you have to do y plus 3 at the top and y plus 3 at the bottom. And then over here, well, what does that need? It needs a y. It needs just a 5. And so if I look at that, they would look the same. I have the y plus 3, the 5, the y minus 3 in the left, and I have the y minus 3, the y plus 5, and the 5 in the right. And so I just need to start simplifying the numerator. So if I multiply that out, I should get 4y plus 12 plus 25. And so I know I jumped there, but you should understand y times 4, y times 3 times 4, and then that 5 times that 5. And so you get 4y plus 12 plus 25. Combine like terms in the numerator, and I would say leave your answers in factor form just in case you can see if you can keep simplifying. So that's how you do that. So now let's do our last example. All right, so it says combine the following fractions by factoring the denominators and find the common denominator and add. Okay, so let's factor first. So I'm going to keep this like I'm doing my work. I'm not going to really work on the side. I'm just going to keep my work going. So we need to factor those. So to factor those, we probably need to do a tree on the side, on little x. So we have 20 and negative 9. We don't have to do grouping because the x has a 1 in front of it. So whatever two answers we get, we know we can drop those straight into parentheses. So what two numbers multiply to give me 20 but add up to negative 9? So I would hope you say negative 4 and negative 5. So we have those. So let's go over here on this other side to do the other one. So we have 8 and negative 6. So what two numbers multiply to give me 8 but add up to negative 6? Well, I hope you say negative 2 and negative 4. And so we have our factors. All right, so here we go. So let's write them. So notice I just rewrote that x squared minus 9x plus 20, wrote it like that, and then I rewrote that. So now the only thing I have to do now is I need to try to make them the same. The denominators have to be the same. And so the easiest way you can look at it is, well, what would it take to make them all the same? So if I look to the left, which factor does the left one not have? Well, it's already x minus 4 over there. I don't need to add that. I need to get this one to have an x minus 2. So over here, and let me erase my factors so they won't get in the way. Okay, here we go. So I need an x minus 2 on that side and an x minus 5. And when you look at that, we have all three binomials, okay? Now, hard part over here, we need to multiply this out. So you are going to have to work on the side and multiply that out. So notice what I'm doing over there, x minus 2 times x minus 3. So this right here is going to turn into that for my numerator. That's easy to do because all I have to do is 2 times x and 2 times negative 5. And so all as one, I get all that in my numerator. So then I can combine like terms, and there you go. And then the last part, the kicker is, if your numerator looks like it can be factored, you're going to have to factor it. Again, it all comes back to factoring, which is why I said it's the most important thing in Algebra 2 to learn. You can't ever forget factoring. So I'm going to go over here and make my factor tree. So I have negative 4 and I have a negative 3. What two numbers add up to negative 4? I mean, multiply negative 4, but add up to negative 3. I would hope you say negative 4 and a positive 1. So I know that's what's going to go in my numerator. Now, if you look at that, what do you now see that you learned how to do with simplifying fractions and multiplying rational expressions? Well, right there. That baby's gone. And so my answer is really x plus 1 over x minus 2 times x minus 5. All right, now this is a lot to take in. I'm not going to lie. It is a lot. So I am definitely having a Zoom here. So hopefully you will see the time that I would have the Zoom. I apologize for not having it during the class period, but honestly, I don't wake up that early anymore. I am doing this at 5 o'clock in the morning. Take that back. It's 4:45 in the morning when I'm doing this. Therefore, I have to do later Zooms. So here you go. I'll have to work at night because I'm working so hard with my baby. So it just is what it is. I get it done when we can get it done. So there you go. Please check out the next video on subtraction. It works the same way. You just have to worry about the minus sign. So you guys stay safe, and I hope to see you in the Zoom meeting for help if you need any help on what we've been doing. Talk to you guys later.